Hello, everybody. Welcome to the first official episode of Adventures in History. Whoo, history, awesome times, gotta love it. Thank you, everybody, for being here. My name is Shane McInnes. I am a history instructor at a community college here in Mississippi. I have been teaching now for going on 13 years. History is my absolute passion, and I hope that through this Twitch channel, you are able to get just a little bit of that yourself. I don't know if I can send the vibes through the TV to everybody, but hopefully this will be a fun time. So today, the first episode, what I wanted to start talking about was how we know what we know, meaning basically how we understand history and how we think about history and how we've made our minds up about how things in history have happened. I've got a couple of things, just sort of a little bit of a housekeeping thing to mention here before we get kicked off in full. Also, trying to riff here a little bit just to give the room a little bit of time to fill up. First off, you can see my email address, which is, I do this every time, it is right here. mckinnistravels@gmail.com. If you have any questions at any point about anything that you run into, please feel free to send me an email. Don't forget to click the follow button, which is up in this little region over here. It's a little heart, and it will follow. That'll tell you when I'm online. And beside that, there should be a little bell button that you can use to set notifications if you want to be notified via text or email when I do go online. Based on current feedback, it looks like this time, somewhere around 7 Central on Thursday afternoons, is going to be the sort of accepted time for a little bit. If I get a lot of feedback that says, no, do it on another night, I will do it on another night. That being said, I do have to correct one thing. I did a bit of a soft open last week, and I made an error. Which is going to happen. I am prone to error, just as everybody is. I stated that my mother had been teaching for 43 years before she retired, and in fact, she actually taught for 44 years. I do not want to shortchange her that, and I am absolutely not making fun of that at all. Every year past the first year is just a little bit more icing on the cake. So my mom is awesome. She's been a great role model. Both of my parents are pretty great. Awesome sauce. All right, little bit more, and I'll be just about done before we can move into this stuff. Nice shirt, yes. This is another Mouse Guard shirt here. David Peterson, gentleman typing here in the chat, is actually the writer and author of Mouse Guard. Does a lot of really cool artwork on stream, and recently he's been reading through one of my favorite books, Wind in the Willows. He's also read through a lot of his stuff, so if you click his name, it'll take you to his channel, and if you're interested, click follow, and it'll let you know when he's online. Really cool guy. There is a delay. So if you have any questions that you want to type in the chat down in the corner here, it'll take me a little bit. I've been told that it's about 30 seconds before I get a chance to see it. So if you ask a question and I don't immediately respond to it, give me just a little bit of time. I'll see that. And I promise that I'll try to answer all of your questions, or one of my mods will beat me about the head and shoulders and get me back on track. Okay, so kind of launching off here, I want to explain a little bit about why I chose this topic to begin with. It's a two-part series. Today we'll be looking at how we know what we know from prehistory, which is actually the vast majority of human history. And then next week, we will look at how we know what we know based around a little bit more modern typed scenarios where we have writing and settlements and things like that. So if you were with us last week, you'll know that I mentioned that as a kid, I asked really weird questions. I always wanted to know the weird stuff, like the behind the scenes stuff. And one of the things that I very frequently got not necessarily in trouble for, but sort of chided on when I was in classrooms was, how do we know that? I was an inherently interested kid, and this wasn't me being super skeptical all the time. This was just like me honestly wanting to know how do we figure that out? You know, so you're in biology class or chemistry class, and the teacher says something, and they just expect you to accept this as a fact. My brain doesn't work that way. My brain goes, how do we know that? And I never really got that answered for me until I got to college and started taking upper level history classes. And once I figured out how we do know a lot of this stuff, it made me a lot more appreciative of the things that we do know. And I wanted to start off talking about this because I don't think you hear a lot of people talk about this stuff. Usually when you pick up a history book, it's just a whole bunch of facts and they don't really explain a lot of things. You might see a picture every now and then of some relic or of painting or a reference to some ancient text, but you never really get a full explanation of how historians have put that stuff together and how we've actually come to understand that this is the way that things actually work. So again, I've broken this into a two-part series, and today I want to talk about prehistory. So first off, a little bit of a definition of a term. Prehistory is what people call history before history was written down. So what we're talking about here is history from before writing. And if we understand the idea that human beings have been around for a lot longer than writing has, you'll know that prehistory then is the vast majority of human history. So the recorded version of history that we actually call history is therefore way short. And if we're getting really, really generous, we could maybe push that back to somewhere around 4,500 years ago, but that's being very generous. So what is up with this description of prehistory? When did humans first show up? Why do we even care about all of this stuff? How does this relate to us? Well, hopefully I'll explain all of that a little bit today, or tonight rather. And as always, please ask questions if you have anything or if I say anything. Again, I've got my neat little notepad straight here below me that I can type on and give you some things maybe to Google later on. So if we accept that human history as an entire concept from the beginning of the first humans is a sort of monolithic topic, we're going to get in what dates are you using for humans using writing. So what I'm saying here is specifically using alphabetic script of some sort, not pictographic writing. In the sense, there were pieces of writing that go somewhere back to the 8,000-9,000s BC range in places like China. They're not necessarily fully derived languages. What I'm talking about here are the first actual alphabetic typed languages that we know of, those being the Sumerian languages in Mesopotamia using the cuneiform writing, and just soon after that, Egyptian hieroglyphics. Those in Mesopotamia are dated, if we're being very, very generous, to somewhere between 2200 BC. And there are evidences of pieces of writing. Oh yeah, hieroglyphs are definitely in. The cuneiform in Mesopotamia beats them by a few hundred years, but they develop roughly in the same sort of strata of levels of culture there. And we will definitely talk about that later on, and once we kind of get into the actual historical narrative of things. History is written by the winners. I think that is absolutely accurate, Kyle. That is definitely the way that it is. And another thing that I could say to sort of alter that statement is that history is also destroyed by the winners. When you see a lot of these ancient cultures take over somebody else, there is a very frequent sort of method whereby people go about eliminating historical past data. Like, this king takes over and he goes to the temple that his predecessor built and scratches the name off of the temple of his predecessor and puts his name on it. So not only written by the victors, I would also say perhaps edited or changed by the victors. So yeah, that's an important thing to remember as well, that a lot of the stuff that we have is going to be shaded through our very own human interactions. And we'll talk about that a lot more in part 2 of this discussion. So to sort of get to the beginning of what I call a human, you have to kind of ask yourself what is a human being. And for the course of this particular discussion, I'm going to use Homo sapien to mean human. So if we understand that Homo sapiens are humans, when does that prehistorical event happen? Somewhere between 200,000 and 220,000 years ago, you're going to start seeing the first solid, indisputable evidence of modern humans. And the earliest site that we can point to that is undisputed right now is some remains that were unearthed at a place called Omo Kabish, which is in Ethiopia. Those are dated to right around 200,000 BC. And I do want to note, and if people are actually interested about this sort of evolutionary path of humans, I would love to talk about that in a discussion later on. But there is a lot of debate in this area amongst anthropologists and paleontologists and archaeologists and historians about what counts as a human, what isn't a human, where humans started, where humans stopped. So I'm using here this idea that this is the sort of indisputed level of where humans first show up. So if we're talking about something from 200 to 220,000 years ago, the life of those people on a day-to-day basis is way different than ours, right? And we have to think about that and understand that when we try to understand them as a whole. So first off, these people don't live in houses, right? Many of them don't even live in the same place. They're still very nomadic. People are moving around a lot. And because they don't live in homes, they're also going to have very little stuff, what we call physical culture. So everything that is around us that we can touch that plays a part in our life is physical culture. So like the computer that I'm using, but also the shirt that I'm wearing and the lights that are above me. Anything that somebody in the future could dig up that is an artifact that could tell them something about me is called physical culture. So these people did not have a lot of physical culture that is made out of things that are going to last, right? So our earliest examples of clothing are all going to be hides or grass or some sort of material that if you just leave it sitting out in the dirt, it's going to rot and it's not going to be preserved very well. We actually have very few archaeological pieces of clothing. There has to be a specific type of environment that exists around those. We don't have a lot of old clothes because they're made out of perishable materials, right? A lot of the tools that they're using are simple tools. And when I say simple here, I'm meaning not compound tools. What we're talking about here is like sharpened sticks and pointy things. They're using stuff that doesn't have a lot of work that goes into it. They're sort of 1 or 2 use tools. So all of that stuff, like if I sharpen a stick and I use this for defense, but then I get tired of it and I throw that stick down, well, that's not going to be preserved in history. So we don't have a lot of this stuff to go on. That's what I'm trying to get at. We also don't have a lot of physical human remains either, because we don't get a lot of burials, right? For almost half of human history, we don't bury our dead. We're marching through the wilderness and Jimmy dies and, we might kick him down the backside of the hill, but we're not going to stop to bury him. And what that means is Jimmy's body is exposed to the elements and Jimmy gets eaten by whatever animal moves around and the bones get scattered out. They're not usually in any sort of single area. So a lot of the pieces of humans that we have dug up are not complete skeletons. They're very disparate. We might find a finger or we might find a part of a skull or some teeth. But we don't have burials in the human nature. And even buried bones do break down. That's right. So depending on how we buried them, we have to be in a lucky position where when people are getting buried, they're being buried in a way that their bodies are preserved. Oh, yes. And to give a brief note about Jimmy, if your name is James or if you go by Jimmy, I wholeheartedly apologize. I use Jimmy as a teaching tool all the time. All of the horrible stuff in the world happens to Jimmy. Jimmy gets the plague. Jimmy is the one that has to eat the berries to see if they are poisonous or not. Jimmy is the one that checks the cave to see if there's a tiger inside of it. I get that, by the way, from Seinfeld. So if any of you all know anything about Seinfeld, one of my favorite shows, I'll reference it frequently, I promise. There's a guy on Seinfeld that refers to himself in the third person. Jimmy would like to date Elaine. Exactly. So Jimmy is the guy that I use as an example for everything. And we will hear lots more about Jimmy, I promise. If we're looking at a historical point of view and we're trying to find the first evidence that we have of an actual burial, the closest thing that we can point at is a place in Israel called the Sakul Cave, and it dates to around 100,000 years ago. So if we're only going to be able to look at about half of human prehistory, that's not even giving us that's only giving us half of the story of humanity. So we don't know a lot of this stuff. And one of the things that I've come to appreciate as I've done more studying in history is how amazing it is that we even know what we do know, right? How we figured all this stuff out is super impressive given the scant amounts of evidence that we have. So to kind of get back a little bit to a point that David made, even when they did start burying people, there have to be specific conditions that exist for those bones to remain, right? So if I get buried by a riverbank, my bones are going to get scattered. The natural flora and fauna are going to break those down much more rapidly. The burials that we're talking about in the Sakul Cave in Israel are not even really elaborately done. They don't have any sort of a casket. It's mostly just a person who's sort of been positioned. Oh yeah, Jimmy is the guy that makes everything happen. I don't know, I'm jumping back and forth, but I'm trying to read the chat and keep up too. So again, the burials that we have are very, very basic. They're not using anything like caskets or any sort of preservative thing. This is an evidence of early religion, though, and we'll talk about that a lot more later on. So if we don't have a lot of evidence and we don't have a lot of bodies and we don't have any homes to go dig around in, how do we even know what we do know? We go out the woods, we start digging, we find a bone. How do we know anything about that bone, right? So the first thing that I want to talk about is something called radiometric dating, which I'm pretty sure that everybody has a little bit of knowledge about. You've heard about carbon dating or something like that, but I actually do want to sort of explain how that works a little bit. I promise I'm not trying to patronize anybody, so if you know all of this, just follow along. Maybe you can correct me in the chat. One of the things that's really important to understand in historical terms is this concept called stratigraphy. It comes from the word stratus, meaning layer, right? So if you go out to a geological site or an archaeological site, you will see them doing excavations in layers. And if you've ever seen a picture of something like the walls of the Grand Canyon, and you see the little stripes of different colored stuff that are moving from top to bottom, those are actually geological strata. And through the use of geological, scientific, and historical tools, we can date those based on the chemical composition of the stuff that they're made out of. All right. Of course, carbon dating is the most important one not the most important one, the most commonly known one. But there's also something called potassium-argon dating, which extends this a little bit further back into the historical timeline. So effectively what we're talking about here is that all material that is in some way or another organic and certain examples of inorganic material have radioactive properties. Now, of course, the stuff that we're talking about radioactive don't mean that I could go out and pick up a big rock and make a nuclear bomb out of it. But the element potassium is actually somewhat radioactive. By the way, if you're walking through your house and you pick up a banana, that's probably the most radioactive thing around you. But we are radioactive as humans in a lot of ways. A lot of things made out of carbon are radioactive, but potassium over time changes to another element called argon. And scientists have watched the decay of this in a lab and they have timed out how long it takes for potassium to change into argon. So when a particular thing is excavated, you can take that and look to see what it's chemically made of. Or you can take elements of the strata that it's in. So if we're talking about a human bone here that's been buried in the dirt for 100,000 years, the material around it might be a particular geological strata. And you can take elements of the dirt or the rock that it's in and send it to a lab and test it, and you can tell about how old that is. So potassium argon dating is a lot more broad when it comes to the time frame that it can be used. It has a minimum limit of 1,000 years. So if something is less than 1,000 years old, potassium argon dating isn't going to work at all. But the range goes from about 1,000 years all the way back into the billions of years. So you can go way back before humans were even a thing. You can go back before hominids were even a thing and get an idea of what this geological strata is in. So if we find a bone, it's in a strata, we can test that strata, we can say this bone is within this range of history, right? Now, one that we're familiar with, of course, is carbon-14 dating. Carbon-14 does the same sort of thing, but it's not as versatile. It works only on things that are organic in nature, and it only has a range of about 70,000 years. But most of the stuff that we have used to sort of build our knowledge of history is going to fall within that 70,000 years range, right? So that goes back to the very earliest times when humans were first migrating out of Africa and into other places of the world. So we're going to get a lot of mileage out of carbon-14 dating. Carbon-14 is going to change into nitrogen, by the way, if you're just wondering what the other element was. There's another sort of newer technology that's come out recently that has really brought in a lot of geological elements, and it's called magnetostratigraphy. And this is something that's still being tested out. It's pretty well done, but it's not necessarily as accurate as some of the other ones. Effectively, though, if you look at elements within a strata and you can find metallic elements, you can sometimes tell where those metallic elements have been aligned in relation to the Earth's magnetic field. And we've known over time for a while now that the Earth's magnetic field sort of moves and changes. And based on the orientation of those little metallic isotopes inside the strata, we can actually get an idea of a time frame out of that, because we have traced through geological means where the Earth's poles have been, magnetically speaking, right? So there's another one. That one is only a little bit useful historically. The opening range is about 20,000 years. So if it happened more recently than 20,000 years, magnetostratigraphy is not going to work. But the benefit here is that magnetostratigraphy goes all the way back to basically the formation of Earth. So it is very long reaching back through history. One thing I do want to note about all of this radiometric kind of stuff is that there are a lot of things that play into this, right? It's not just, oh, you go find something made out of carbon. Oh, we've got carbon. Woo! And then it works. There are a lot of things that go into accurately dating something. The location itself has a lot to do with this. So very specifically, the type of material that the remains have been found in have a lot to do. If you're in a very carbon negative area, or if you're in a very carbon abundant area, this is going to potentially have effects on the actual artifact itself. The atmospheric conditions at the time that the artifact was put into the ground, if we're talking about a guy here, if Jimmy's walking around and Jimmy dies, what was the atmosphere like when Jimmy died? And that is going to change over time. At different times in the Earth's history, there have been more and less carbon in the atmosphere, right? So you have to take that into account. There are also things like, very basically, like the sort of composition of the material itself. Like if we're talking about human remains and we're talking about bones are going to decay slower than flesh. And I know that seems kind of weird to talk about. So that is going to be something that you have to take into effect as well. So Carbon-14 dating is usually going to have a range of about plus or minus 80 years. And I know that seems kind of weird, and to say, like, like if I asked you how old you were, and you say, oh, I'm 36 plus or minus 80. That seems kind of dumb. But when we're talking about a range of 70,000 something years, and you guess within 80, that's pretty daggum good, right? That's easily making an A on the exam. So you'll see a lot of people that are opponents of carbon dating being used as a historical element criticize it a lot because, oh, it's just so inaccurate. And what they're talking about are those variances, how scientists have to be very careful about estimating things, and there are a lot of things that go into it. You can't just give a raw output sometimes and say the test said 15,000 years old. Sometimes you have to adjust that based on the location and the atmospheric conditions and stuff like that. There's a lot of criticism, by the way, from certain elements of the historical world that don't like carbon dating. I personally, opinion here, I personally don't see anything wrong with it. I think it is an amazing tool, and it has opened up windows into our past that are absolutely essential to our understanding of the ancient world. All right. So radiometric dating is one thing, but there's also DNA, especially once we get into a little bit more recent time frames. We can actually recover DNA from human remains. And I know that's cool enough as itself, but you might say, why do we even give a crud about DNA? Well, here's the thing about DNA. We can measure the amount of mutation in DNA. And scientists have done a lot of work on this since the discovery of DNA. And I say we as if I'm some sort of molecular biologist. That's actually my wife. I'm sorry, I hear her correcting me in my head. She's not a molecular biologist, she's a microbiologist. There is a difference, and I said it wrong. Apologize. Sorry. Anyway, scientists have discovered that there are somewhere between 100 and 200 mutations every generation of humans. And you might think, holy crap, I'm going to end up with my kids coming out with Cyclops I-beams. Or, magnetic powers like Magneto or something like that. But what that really kind of... oh, I had it right the first time. I apologize. My wife does stuff that I don't understand because she is way smarter than I am. What I'm trying to get at here is, if you look at how fast humans are going to have genetic mutations, it's about one genetic mutation for every 30 million pairs of DNA strand that we have per generation. And that is very, very small amount, but it is something that we can sequence now, and we can tell. And what we can use this to do is actually create a generational model of how long a person has been dead, right? So if Jimmy dies and we find his body and we are able to recover DNA from this guy, we can sequence his DNA and then compare it to living DNA from people that are native to the same region. And we can actually see how much the DNA mutations have changed Jimmy's DNA to the modern person's DNA and get a better idea of how many generations lie between the modern person and Jimmy. And that can help us narrow down a lot of stuff when we don't have other good information. For example, if we don't have a good geological strata that this person was discovered in. Their remains were just discovered on the floor of a cave. That's a lot harder to sort of pick apart when we don't have any other pieces of evidence to go along with. But DNA recovery is really, really difficult. DNA is a chemical that will break down over time. It's not permanent. And especially if a bone fully fossilizes, there isn't anything carbon or organic left to it. It's literally become a bone at that point, and DNA can't be extracted from it. So these DNA strands degrade over time, and that means that if we do find something, the older it is, the harder it's going to be for us to recover pieces of DNA from that. And to date, the best things that seem sort of interesting and most easy for us to get DNA from are teeth, especially back teeth like molars. There's been some evidence that's been discovered from leg bones, especially the femur. Every now and then you can get some stuff out of a finger or a toe. But teeth seem to be the sort of way to go. If you can find some good back teeth from some of these people, you stand a lot higher chance of getting some DNA out of it. But even if you do get DNA out of it, it doesn't mean that the DNA you get is going to be a full strand, right? So if we're looking at a chain, and our chain has 10 links in it, over time, some of those links are going to fall apart. And you might get links 1 through 3, and then link 6, and then links 9 and 10, right? So you get these little fragments of DNA. And it's hard sometimes to tell what those little fragments tell us about the particular person's DNA strand. But thanks to science, we have new technology that will allow us to sort of amplify the little pieces that we find to try to figure out where they fit in the overall chain. And there's a particular process called polymerase chain reaction. It's usually referred to as PCR. Here, let me... So if you want to Google this stuff, it's actually pretty neat. What this does is it takes little pieces of DNA and it makes lots and lots and lots and lots and lots of copies of them so that you can find particular pieces that are going to link up with certain genes, or get some pieces of that material that you can sort of play around with without destroying the original material, things like that. So you can make this a lot more versatile with something like PCR. Pretty neat stuff. My wife actually tried to explain to me how PCR works, and I know it has something to do with gels and putting stuff in, and it went way over my head. So when we're looking at human DNA, what's the oldest DNA that we've figured out? Well, we've recovered DNA that reaches back to around 100,000 years ago, which is right around the same time that we get burials. And in fact, some of the earliest DNA that we have found comes from early burials. That burying people, man, fragments of DNA. Hello, man, with the PCRs. Fragments of DNA definitely sounds like a 90s post-grunge band where everybody tries really hard not to be Metallica, but they end up sounding just like Metallica. It's also how you do baby daddy testing, right? So DNA testing is becoming easier to do, and it is definitely becoming a larger piece of the puzzle. It's giving us a new way to express things that have happened in ancient history. It has also given us a lot more of an idea about how people have migrated. And human migration in prehistory is one of my really big pet projects. I love the topic. And I will definitely bend your ears about that in the future. There is a particular... I don't want to get too far into that. I'm almost getting there. I need to stay on topic. Stay on target. We'll talk about human migration and how DNA plays into all of that, and I'll show you history of stuff later on. Let's get through this one first, right? So anyway, oldest DNA is around 100,000 years ago. Burying Jimmy helps us out, right? But there are other things that we can use as well, not just specifically on the remains or around the remains. There are a lot of what we might consider like environmental elements of things that we can look at to try to explain what we know about stuff, right? So how do we know what we know? Well, it's not all just based on the artifacts themselves. Sometimes we have to look outside of things that are sort of traditionally considered history or archaeology to find answers for stuff. And that's one way that science has really, really helped history. With the advent of all of these new technologies, we really have done a whole bunch of stuff. There are so many new arguments inside of anthropology now based on old DNA evidence. Some of the stuff that's really cool that's being done over here in Egypt, of course, these guys are really big on preserving their dead. So this is the Nile River right here. It is going to run right through the ancient areas of Egypt. The Egyptians are super big on burying their dead. They have these really elaborate customs of burial, and that is amazing because of DNA stuff. One of the projects that's actually going on now inside Egypt, that's actually being funded by the Egyptian government, that has a really big archaeological element. Government-funded archaeology, something that we don't have in America. We probably should. Soapboxy. Moving along. One of the things that they're doing with DNA in Egypt is actually building a family tree of all known mummies. And there had been a lot of debate over which person was who and which mummy was what. Especially during the tumultuous periods of Egypt, a lot of the really big and cool burial structures get wrecked, right? All of the pyramids get sacked. A lot of the big tombs get sacked. And some of the priests that were really big around preserving the bodies of the ancient pharaohs very frequently did this thing where they would suspect that things are going to get bad, right? Like, the big pharaoh died and there's a big war that's brewing. They would actually go in before the tomb robbers and collect the mummies and hide them all in these sort of separate, very unadorned kind of hidey holes. But that also eliminated a lot of the evidence that we would have to go, who's this guy? Who's Pharaoh Jimmy here? So they have started doing DNA testing, and through that they have been able to identify this guy is this pharaoh because he is the father of this guy. We know that this guy was buried in that tomb because of DNA evidence. We now know that we have the mummy of this guy. And that is so cool to me, that science can help history out like that. I'm getting a little excited, but that will happen too. Again, I'm a giant nerd. I like this stuff a lot. Okay, so what I was talking about here are environmental elements that we can also use to help with chronology. There are 3 or 4 of those that I want to talk about. The first one being sort of a new thing that's happened in the last 20 or 30 years, using sediment layers. And if we find old bodies of water, especially lakes or ponds, sometimes in rivers, if you can find an area where the current isn't too fast, but definitely in lakes and ponds, especially parts where the water is not moving, the sediment on the bottom of the lake over time is actually going to catch all of the stuff floating into the pond. So a bird flies over, drops a feather that goes into the pond and eventually ends up at the bottom. Plants are going to spit out pollen that lands on the top of the water, ends up in the sediment at the bottom. And you can take these big drill cores and actually drill down into the bottom of these lakes and pull out this kind of layered muck. Fish poop, right. And the fish poop is actually an important marker because it tells you how much activity is going on. And through stuff like sediment layers, there has been a growth in a new field called paleoclimatology, where people are actually looking at physical evidence that's left over to explain the way that the climate was at specific times in the past. And that goes hand in hand with the kind of stuff that we've been talking about already, right? If we find out from paleoclimatologists that a certain period of time was very seismically and volcano active, right? There's a lot of volcanoes being spitting around right here. There's a lot of earthquakes going on. And we know that because of the large amount of ash in these layers of sediment at the bottom of this lake. Well, what that also tells us is that there's a lot more carbon in the atmosphere. And what that might mean is that we might need to then go back to evidence that we've already collected through stuff like carbon-14 dating and adjust those dates a little bit, right? So, oh man, there's a lot more carbon-14. This thing might actually be older than it looks. And it's possible. So these sediment layers, fish poop created climate change is a lie. It's not the fish poop that we're worried about. It's how much fish poop is there. right? Because at very high temperatures, fish don't live in ponds as well. Fish like nice, cool things that are in that habitable range. If the water gets too hot because it's too hot outside, the fish die off and they don't poop anymore. So climate change happens and that affects fish poop. It's not fish pooping that create climate change. It's ex post facto kind of fallacy there. So paleoclimatology is a really interesting area. There have been a lot more papers published about that in the last couple of decades. It's becoming a very big thing, especially, when we've sort of identified the climactic cliff that we're sitting on right now. People have wanted to know a lot more about how the climate has acted in the past. So how did humans react when the climate did this, or how did it react when that? What happened with mass die-offs, and were there more fires because of this stuff, and did the environment react this way or that way? And they're using that to sort of try to predict the future. And this gets back to something that I talked about in our first discussion, that one of the biggest values of knowing and understanding history is that you can use it to sort of then guess about what's going to happen in the future. Because, the thing about science is once you've proven something is a scientific fact, that's the way that it is. Despite certain particular individuals in the world believing that there are such things as alternative facts, no, there is objective truth and then there is not. And that's the way that it works. And I know that makes people uncomfortable, but sometimes being uncomfortable is a sign that you need to change. I know that was super preachy, and I'm not going to try to get super preachy very much, so hopefully that did not turn anybody off. If it did, I'm not going to apologize. All right. Another thing is the growing field of paleobotany. And I know everybody woke up today and was like, holy crap, he's going to talk about paleobotany on stream today. I'm super excited. But paleobotany is really cool because it's how Laura Dern's character figured out what the Stegosaurus, no, it was a Triceratops, what the Triceratops had eaten that made her sick, right? Because she was a paleobotanist. Paleobotany is using plant-related material to talk about the past. And this has been, to me, one of the most fascinating fields that's been growing lately. One of the reports that I just read not too long ago was about some burial sites in Iraq that stretched way back into the Middle Stone Age. And the particular person in question had been buried, and around that person had been scattered all of this red ochre and all of these flower petals. And one of the things that the authors did, the authors were, the people writing this paper were the people that were doing the excavation. Once they found all of these things, what they did was they immediately reached out to a paleobotanist and said, we need to get you to this site ASAP. And one of the things that the paleobotanist did was literally take dirt, just regular old dirt, from the surrounding area around this person that had been buried back in the Mesolithic age, and run that through a screen, and then stared at the dirt under a microscope and started pulling out little pieces of archaic pollen. And they could tell from that dirt that the person was buried in a little bit more about the time period itself. They could say, oh, this person was probably buried in the spring because there was a whole ton of pollen in this particular thing. Of course, that's also evidenced by the flowers, but they could even tell you a little bit more about the plants in the surrounding area. And it turns out, back at that time period, Iraq had a lot more green stuff than it does today. And these are little pieces of evidence that we did not have back when archaeology was first invented back in the late 1800s. Everybody back then was just a white dude trying to dig up something and put it in his study, right? But this new paleobotany stuff has given us a window into the past that we've not been able to have before, all right? Another thing that I can tell you about is there are certain bodies that have been discovered in very well preserved states where they have brought in paleobotanists to examine the contents of these people's stomachs. That could tell you then what type of plant that they were eating, what type of stuff that they were breathing into their lungs, and give us a little bit broader picture of the way that these people lived. And that might seem sort of inconsequential, but when you're building a picture of 200,000 years of human history, and we only have a few hundred pieces of this, multi-thousand piece puzzle, every little thing like that might be the thing that helps us make a breakthrough, right? So that stuff is it belongs in a museum. It does belong in a museum. I almost used that sound clip as part of my audio here, but I didn't. So last thing I want to talk about is ice cores. Up in several parts of the higher elevation part of the world, especially up in Greenland, up in the Arctic, and to a certain extent down in South America in the Andes and some of the big glacial deposits there. Scientists and geologists have been using ice cores to determine a lot of stuff. So the way that ice cores can be used is you do similar to the sediment stuff at the bottom of a lake. You drill down into this glacier and you pull up this big tube of ice. And inside of the ice, there are lots of mineral deposits and lots of little bubbles. And those little bubbles are actually air that was originally captured when the snow first fell on the glacier, right? So imagine we're up in northern Greenland. We're standing on the top of this glacier and it's snowing, right? So the glacier that's under us is the composite element of probably, 10, 15,000 years of snow. That's just been mushed down over and over and over and over again, right? Well, when the snow is falling as a precipitate, it lands on the top and it doesn't form a homogeneous layer. It's got little bits of stuff in it, right? Stuff out of the atmosphere, little pockets of air. And you can drill into those little pockets of air and examine the types of material that are there to do stuff like figure out what the atmosphere looked like. You can find little bands where things are really dirty and do examinations of that and figure out, oh, that's an ash layer. Well, what happened to put a whole bunch of ash in the atmosphere? Well, maybe, Mount St. Helens blew up or something like that. Maybe this was Krakatoa. But these ice cores are going to be able to give us a picture of atmospheric conditions and global conditions going back thousands and thousands of years. One of the coolest examples of that I can give you actually comes from a paper that came out back in 2018. There were some historians that were able to access some of this ice core data and worked with some of the people collecting the ice cores. And they found a specific band of ice that had several little layers in it. And they asked... the historians asked the ice core people, what time frame does that sort of respond with? How does that line up in history? What are the years that you think this, chunk of ice comes from? And they said, well, it looks like it's probably from about 300 BC to probably around 300 or 350, 400 AD. So the chunk of ice had lots of little lines in it. And so these historians said, well, that corresponds with Rome. I wonder if we can find anything out trying to line up the events from Rome to this ice core. And what they actually found out was they could track the Roman economy using an ice core. Now, how in the devil do you do that? Well, it turns out that the Romans had a very specific way of smelting, specifically silver, that gave off a lot of lead pollution. And this lead pollution got up in the atmosphere, got carried on the air paths up in the upper atmosphere and deposited in these ice cores. And they could line up these big deposits of lead with the growth and expansion of the Roman economy. So when Rome was making more coins, there would be more lead, which seems pretty cool to me, right? Ice cores are pretty neat. I've dug around in that information a whole lot. When we get to human migration, I'd like to talk about ice cores a little bit more. A lot of the stuff that I'm talking about is things that I would like to revisit later on. So I'm about to kind of wrap up here. I've got a little bit more, but I want to open up for questions if you have any. And again, I'm doing this now because there's a little bit of a delay between what I'm saying and when you type back to me then. So go ahead and type in questions. I'll sort of wrap up and then I'll answer questions if there are any. So to wrap all of this stuff up, if we're looking at human history, again, we have prehistory and we have history. History being about 4,500 years if we're being generous. That is, again, 0.02% of human history. So all of the stuff that we know about, like even ancient Egypt and Sumeria and human migration patterns after that period of time, and we're big cities and civilizations and China fighting the Mongols and all of that stuff that has happened that has been in recorded history is 0.02% of human history. We first showed up 220,000 years ago. How much of that do we know? And it would probably surprise you that we know actually a pretty good bit about it, or it might not surprise you. I don't know how big of a fan of history as you are. I doubt that anybody is quite as fanatical as I am about it. But we know a pretty good bit about these people. And it's because of this sort of stuff that I've been talking about tonight, where we can look at the surroundings of these people. We can use scientific knowledge to try to help us figure out when these people lived, how they lived, and get a better picture of the world that they lived in. And that is going to give us so much good information. One of the things, again, that I want to try to make as a sort of overarching theme for my entire discussion here is these ancient people are not so different than we are. They lived a long time ago. They have drastically different day-to-day lives than we do, but they want the same kind of thing, right? So when we start looking at the move into history and the move into sedentary life, what people are going to want is the same things that we want, right? These people in the ancient world in prehistory didn't have homes. They were constantly worried about where their food is going to come from. They had predators around them. They were having all sorts of problems with other groups of people, right? So those are things that challenge humans on a basic level, right? You want your family to be able to sleep safely. You want to go to sleep with a full belly. You want to have a nice place to kind of raise your kids in and make sure that their future is a good place. And these ancient people want the same thing that we do, right? So here's a question from Gabriel D. May. Since prehistory is the time before writing, do we have any evidence of political institutions from a non-textual evidence? Yes, we do. What we can actually look at as humans are moving on the trajectory, right? So we start off around that 200 to 220,000 year mark being very, 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 very intelligent animals. And I don't want to I don't want to shade that. Humans are animals. And when we showed up, we have only the scarcest amount of what you might call today society, right? The same type of society that you would see in any other animal. We had not really figured out that well how to do stuff like pass down knowledge. There is very little evidence of early language. We're really not even sure when the first spoken languages were really sort of formulated. But as humans move through time, we become better at those things and we start passing down our knowledge to people. And by the time we get to around the big migration points, and what I'm talking about here are the period of time from about 100,000 to about 30,000 years ago. So for that 70,000 years, humans are in really big migrations. And these are the migrations that are populating the continents with Homo sapiens. And even that model is very sketchy, so don't get too deep into that. What we do see, though, is an organizational element where the population spreads tend to be based around groups of people that are only around between 100 and 150, maybe 200 individuals. And this seems to be a sort of understanding that this is the sort of smallest and therefore largest functional unit of people, right? One of the things that is hypothesized from anthropological and sociological research is that 200 is about as many that can get along at one given time. So what we have brought into the world then is, if we're not getting along, that means that we have started to develop things like societal expectations and cultural elements that are going to delineate right and wrong. And those ideas are going to bring us towards a more sedentary lifestyle. So by the time we get into the 10,000s and down BC, when you start seeing the earliest examples of human settlement, one of the first things that happens once permanent settlements start are religion and government buildings. You're going to see certain spaces that are designated for religious purposes, and you're going to see certain rooms and houses that are just bigger. And that is going to be in existence for probably somewhere between 800, maybe 1,000 years before writing shows up. So in the earliest sedentary cities, you're going to have politics before you have writing. And this is, again, going to get into a little bit of the stuff that we'll talk about next time when we talk about archaeological excavation kind of work. But that is a great question. Not just the predators Dateline catches on TV. I'm not certain exactly what that related to. Do we have any mouse history? There is an amazing amount, and I don't know if that was necessarily meant to be a topical kind of question. By the way, again, David Peterson writes a comic, writes and illustrates a comic called Mouse Guard. There is a growing field of study of how humans and animals have interacted, and stuff like mice and rats, but also domesticated animals like cats and dogs are getting a lot more attention right now. The interplay between the interplay between humans and their natural fauna that surround them is a really growing area of anthropology right now. There's a lot of people looking at domestication as an important tool. Well, I read an article that sort of relates to this from the cat side, not necessarily from the mouse side, but where they're cats or mice, right? And the article was sort of making the joke that cats actually domesticated humans, not the other way around, because cats allowed themselves to be domesticated only because humans were attracting mice. So the cats were doing a favor for the humans because they kept being nasty and smelly and not washing and attracting more mice. So the cats were the ones that were doing the domesticating, not the other way around. I've seen some mouse history from the 1100s. Any sort of time that we're talking about big pandemics being spread, especially Black Plague, anything that has that sort of area, you're going to start seeing a lot of stuff. There's a fascinating illustrated documentary on the subject. Oh, is this all just a joke about Mouse Guard? And I've completely missed it because I've been too... Oh, goodness. I have just received the joke. Thanks, guys. That was great. Pre-literate politics probably are very similar to modern politics. I know that might seem like a sarcastic comment, but absolutely. Human beings are still human beings. Human beings have always been opportunistic. One of the things about our big old brains is that we can be greedy, right? We can be greedy, we can be selfish, we can make long-term plans that put ourselves in positions of power and authority over other people. We can do all of that stuff, and that's been going on forever. Some of the first actual records of history that we get are politics. It's lists of kings and their accomplishments, and it's all done as propaganda. One of the earliest sort of narrative documents that we see related to politics is this thing called the Epic of Sargon, where Sargon, by the way, is a king from Mesopotamia. We'll talk about him later on, maybe. And the whole thing is just, I am amazing. I came from nowhere. I beat up those people. I went to the city. I beat up the red-haired people and the black-faced people. Look how cool I am. So politics is there. I would make a great Calvinist. The problem with that is multifold. We can talk about Calvinism when we get there. I would be happy to. When did ducks become humans? I think that was last year sometime. Calvin and Hobbyist, maybe. All right, guys. I'm sensing that the real questions have expired and that we are into riffing, which is fine with me. I appreciate everybody tuning in. I hope that you got a little bit out of this. Again, if you have any questions, please make sure to send me an email. I keep doing it wrong. It's right there. Again, the follow button is over there as well. It's a little heart. If you click that, you'll be able to know if I'm online. And then beside that, you see the notification button. If you want to get notified when I go live, click on that. Otherwise, again, thanks everybody so much for being here for the first official episode of what I'm calling Adventures in History. I really appreciate the interaction and the questions, and I hope to see you guys next time. See you around.